In this lesson, we will learn how to convert fractions to decimals and decimals to fractions. We'll begin with converting fractions to decimals. Now, as you may already know, the fraction 1/4 is equal to the decimal 0.25. One way to convert 1/4 to 0.25 is to treat the fraction as division. So 1/4 is the same as 1 divided by 4, which we can write this way using long division. We can also use a calculator for this conversion. Either way, when we carry out the division, we get the decimal 0.25, so we know that this is equal to 1/4. Similarly, to convert 5/6 to a decimal, we can think of the fraction as division and divide 6 into 5. When we do this, we see that 6 does not divide into 5, but it does divide into 50 8 times. So when we multiply 8 by 6, we get 48, which we subtract from 50 to get 2. At this point, when we drop a 0 down, we see that 6 divides into 20 3 times. So when we multiply 3 by 6, we get 18, which we subtract from 20 to get 2. Now, it's important to note that we already got 2 the last time we subtracted, so we can expect to continue getting the same results from this point on. Here's what I mean. If we continue along, we drop a 0 down here, and then we can see that 6 divides into 20 3 times. When we multiply 3 by 6, we get 18 again, and from here we subtract 18 from 20 to get 2 again. So as you can see, this pattern will continue forever. So we can say that the decimal equivalent of 5/6 will be 0.83333 and so on, where the 3's continue forever. The bar over the 3 signifies that the 3 repeats forever. Now on the GRE, we can use the calculator to avoid lengthy calculations involving long division, or we can memorize the following conversion table. For example, using this table, we can see that 0.25 is the decimal equivalent to the fraction 1/4 and vice versa. Now you might notice that some of the decimals here feature these squiggly symbols. These symbols indicate that a particular decimal is approximately equal to the corresponding fraction, but it does not equal the fraction exactly. For example, the decimal equivalent of 1/3 is 0.33333, where the 3's repeat forever. So the decimal 0.333 is the approximate equivalent to 1/3. On the GRE, these approximations are all you need. Now, if you can memorize the base conversions on this table, you will be able to make other conversions with these. For example, to convert 3/5 into a decimal, we can use the fact that 1/5 is equal to 0.2. So if 1/5 is equal to 0.2, then 3/5 should be 3 times as large. In other words, 3/5 must equal 0.6. Similarly, to convert 2/7 into a decimal, we must first recognize that if 1/7 is approximately equal to 0.14, then 2/7 must be twice 0.14, which is 0.28. Now please note that since 1/7 is approximately equal to 0.14, we cannot then say that 2/7 is exactly equal to 0.28. So we need to write this with the symbol for approximation instead. Finally, to convert 4/9 into a decimal, we can conclude that if 1/9 is approximately equal to 0.11, then 4/9 must be 4 times 0.11, which is 0.44. Once again, since 1/9 is approximately equal to 0.11, we can only say that 4/9 is approximately equal to 0.44. Okay, now let's reverse the process and learn how to convert decimals to fractions. The steps here are as follows. First, find the place value of the last digit of the decimal, and then write a fraction with that place value as the denominator. Here's how it works. To convert 0.35 to a fraction, we first need to find the place value of the last digit, which is 5 here. Well, we can see that 5 is in the 100th position. So at this point, we remove the decimal point and insert the number 35 in the numerator of our fraction. And then we insert the place value in the denominator. So 0.35 is equal to the fraction 35 over 100. At this point, we can simplify the fraction by dividing top and bottom by 5 to get 7 over 20. So the decimal 0.35 is equal to the simplified fraction 7/20. Okay, let's try another one. The last digit here is 4, and we can see that this digit is in the thousandths position. So to write this as a fraction, we ignore the decimal point and insert the number in the numerator of our fraction, and then insert the place value in the denominator. From here we can simplify the fraction by dividing top and bottom by 4 to get 1 over 250. So the decimal 0.004 is equal to the fraction 1 over 250. Alright, one last conversion. Here the last digit is 2, and this is in the millionths position. So we can write this decimal as the fraction 22 over 1 million. From here we can simplify the fraction by dividing top and bottom by 2 to get 11 over 500,000. So the decimal 0.000022 is equal to the fraction 11 over 500,000. Okay, let's summarize. In this lesson, we learned that we can convert fractions to decimals by using the calculator, long division, or by memorizing the following chart. We also learned how to convert decimals to fractions by first identifying the place value of the last digit in the decimal. In this lesson, we will examine some important properties of fractions. The first property is that any number n is equal to the fraction n over 1. So, for example, 5 is the same as 5 over 1, and 18 is equal to 18 over 1. Conversely, it is also true that 33 over 1 is equal to 33. Another important property is that any number n over 0 is undefined. In other words, we cannot assign a value to this fraction. Here's why. If we think of fractions as representing division, then dividing by 0 is the same as asking how many times 0 will divide into the numerator, and as you can see, this is impossible to compute. Another way to look at this is to consider the following example. When we take 6 and divide it by 2, we get 3. This also means that when we multiply 3 by 2, we get back to 6. So, if we want 6 over 0 to have some value, then it must also be the case that when we multiply that value by 0, we get back to 6. Since it's impossible to have such a number, we simply say that any number n over 0 is undefined. Alright, another property says that n over n is always equal to 1. Notice that we have the condition here that says n cannot equal 0, since 0 over 0 does not equal 1. In fact, 0 over 0 is undefined. Here are a few examples that demonstrate this property. Now, another property says that 1 over some fraction, a over b, is equal to the fraction b over a. So, for example, 1 over 2/3 is equal to 3/2. Similarly, 1 over 11/9 is equal to 9/11. And 1 over 1/35 is equal to 35 over 1, which is equal to 35. In each case, notice that we are merely taking the fraction in the denominator and flipping it. Now this brings up an important definition. The reciprocal of a over b is b over a. In other words, the reciprocal of a fraction is the flipped over version of that fraction. Alright, another property is as follows. The fraction a over b times the fraction b over a is equal to 1. In other words, the product of a fraction and its reciprocal is 1. So 2/3 times its reciprocal, 3/2, equals 1. Similarly, 1/15 times 15 over 1 is equal to 1. And 93 over 14 times 14 over 93 equals 1. Now our next property deals with the consequences of increasing and decreasing the numerator and denominator of a fraction. To begin, if we take a fraction and make its numerator bigger, the effect is to increase the value of that fraction. For example, if we take the fraction 3/11 and increase the numerator to 4, the value of the fraction increases. In other words, 4/11 is greater than 3/11. Conversely, if we take a fraction and make its numerator smaller, the effect is to decrease the value of that fraction. Now what about changing the denominator? Well, if we take a fraction and make its denominator bigger, the result is a decrease in the value of that fraction. For example, if we take the fraction 12 over 3 and increase the denominator to 4, the value of the fraction decreases. In other words, 12 over 4 is less than 12 over 3. Conversely, if we take a fraction and make its denominator smaller, the result is an increase in the value of that fraction. Okay, let's try a few examples. These two fractions have identical denominators, but their numerators are different. As such, we can use the properties to determine which fraction has the greater value. Since the fraction on the right has the bigger numerator, it must have the greater value. Now these two fractions have identical numerators, but their denominators are different. So once again, let's use our properties to determine which fraction has the greater value. Well, since the fraction on the left has the smaller denominator, it must have the greater value. Finally, in this example, the fraction on the right has the smaller denominator, so it must have the greater value. Okay, here are 3 more to practice with. See if you get the following results. Okay, one last property. This one says that if we take a fraction and increase the numerator and denominator by the same amount, the value of the resulting fraction will be closer to 1. For example, if we take 2 over 7 and add 10 to the top and bottom, the resulting fraction, 12 over 17, is closer to 1 than 2/7 is. Furthermore, if we take 12 over 17 and add 1000 to its numerator and denominator, the resulting fraction is closer to 1 than 12 over 17 is. Similarly, if we take the fraction 11 over 3 and add 50 to the top and bottom, the resulting fraction, 61 over 53, is closer to 1 than 11 over 3 is. And if we add 10,000 to the top and bottom of this fraction, the resulting fraction is even closer to 1. Okay, let's summarize. In this lesson, we learned several important properties related to fractions.